Okay, so today first of all we are going to understand loop avoidance mechanism in case of IBGP. Now you are already know what is IBGP, what is EBGP. We had already discussed these things in last class. Okay, guys, if I will ask you the loop avoidance we have in case of distance vector routing protocol, then what will your answer? What loop avoidance mechanism we have in case of distance vector routing protocols like RIP or
Route poisoning.
route poisoning or split horizon?
Oh, sorry, yes, split horizon. Route poisoning is different sets
Uh,
to.
in case of OSPF, link state routing protocol, link state routing protocol designed in such a way so that loop can never form there, you know,
Okay.
because routers are exchanging the database LSAs. So if I have a topology like this, in this topology, if I will configure OSPF, do you think loop can form? No, loop cannot form here. In case of distance vector routing protocol, yes, loop can form here. Router 1 will share the update message to router 3. Router 3 will share to router 2, and router 2 will share to router 1. Sorry, in BGP. In BGP, loop can form here. Router 1 will send update message to router 3. Router 3 will send to router 2, and router 2 will send to router 1. So this is how loop can form in the topology. But again we have one concept in BGP. Because of that, loop will not form here. What is the concept? What is the rule? Rule is, let's say router 1 have one network, that is 10.1.1.0/24. Okay, or before that, let me say here I am using BGP AS number 100. Here also I am using BGP 100, and here also I am using BGP 100. So which type of BGP neighborship will form between router 1 2 or between router 2 3?
IBGP.
IBGP. Okay, so rule is, guys, whatever prefixes or BGP router will receive from their IBGP neighbor, or whatever prefixes a router will receive from their IBGP neighbor, router will never share that update मैसेज और दैट प्रीफिक्स टू देयर अदर आईबीजीपी नेबर. एक आईबीजीपी से रिसीव किया हुआ प्रीफिक्स दूसरे आईबीजीपी को कभी भेजेगा ही नहीं. दिस इज loop avoidance mechanism in IBGP. Okay, so then we have one problem as well. Let's say I have three router like this, R1 R2 R3. Let's say R1 have one network 10.1.1.0/24, and on all routers I am running BGP AS number 100. BGP 100 here, BGP 100 on router number 2 also, and BGP 100 on router number 3 also. Then because of the loop avoidance mechanism, see here loop cannot form, but because of loop avoidance mechanism, when router 1 will share update message right to router number 2 to share this network information. Now router 2 is learning this network from their IBGP neighbor, so it will not advertise to their other by IBGP neighbor, means to R3. Then how R3 will get this prefix? Yes or no? So by default here you know R3 will never receive this network information, because this is rule. If I will configure BGP here, let me configure on router number 1. I have already configured IP address on all router BGP 100, and say neighbor is 12.1.1.2 whose remote AS is 100. That's it. On router number 2 also I am going to configure BGP router BGP 100, and say neighbor is 12.1.1.1 whose remote AS is 100, and neighbor 23.1.1.1 3 remote AS 100. On router number 3 also I am going to say router BGP 100 and neighbor. Who is neighbor? 23.1.1.2 and remote AS is 100. So IP BGP summary, you can see neighborship is fine. On router number 2 also, so IP BGP summary. There are two neighbor, 12.1.1.1 and 23.1.1.3. Now I am going to advertise this TAN network on router number 1. So go to router 1 and say network 10.1.1. First of all, I have to configure the loopback interface. Loopback 1 IP address is 10.1.1.1 255.255.255.0. Now router BGP 100 and network 10.1.1.0 mask 255.255.255.0. Done. So IP BGP, so you can see BGP table. Router have installed this network in their BGP table. After that it is going to advertise it to router 2. So router 2 will also receive this network information, so IP BGP. But see on router number 3, so IP BGP, router 3 is not receiving any prefix. Yes or no? So this is why because we have one rule for the loop avoidance in case of IBGP. So in this type of scenario where routers are not connected in connected in the loop like this, here this rule is working. This rule is, you know, completely applicable in this type of topology. But in this type of topology, because of the rule, in this type of topology R3 is not getting this network information 10.1.1.0. So here I need to break this rule as well. Okay, so we will understand how to break the rule, but this is one rule of IBGP, so you need to keep in mind. After that, loop avoidance mechanism in case of eBGP. So if it is clear to everyone, here loop will not form because rule is very simple. Do not send those prefixes to their IBGP which you have received from IBGP neighbor. Do not send those prefixes to the IBGP neighbor which you have learned from IBGP neighbor. Okay, so sometime we need to break this rule as well, and it is clear that how to break this rule. Now let's say here I am not using AS100, here I am not using AS100, and let me do some change in topology as well. Let me delete this topology and I am going to design one more topology here. In case of IBGP, not IBGP, eBGP, loop avoidance mechanism in case of now eBGP. Can anyone tell me what is the loop avoidance mechanism, guys, in eBGP? No idea?
It should be, I guess, same as this split horizon, I guess.
No, not same like a split horizon. Let's say I have router 1, router 2, then router 3, then router 4, and I have one more router here, let's say router 5, router 6. So here again loop can form in this topology because topology is in loop. This is R1, this is R2, this is R3, this is R4, this is R5, and this is R6. Again here loop can form, and let's say here I am using BGP AS number 100. Here also BGP AS number 100. Here I am using BGP AS number, let's say 200. Here I am using BGP AS number again 200. Here I am using BGP AS number, let's say 300, and here I am using BGP AS number 400. Okay, so see guys, what is rule? First of all, you know, this is concept of BGP, that whenever router share update message to their IBGP neighbor, router never include AS number in the update. When router share update message to their IBGP neighbor, it will never include AS number. So let's say router 1 have one network, that is 10.1.1.0/24. So when router 1 will share the update message, will router 1 include AS number in the update or not? Okay, router 1 is sending update message to their which type of neighbor? To IBGP neighbor or EBGP neighbor? IBGP. So it will not include AS number in the update message. It will not include AS number in the update message. But whenever router share update message to their EBGP neighbor, it will always include ES number. So here it will include the ES number, that is 100 in the update. So now the update which router 1 have sent to router 2 and router 2 have sent to router 3 have one ES number, that is 100 in the update. So when router 3 will share this update message to router 4, will router 3 include their AS number? Again no. Because it is sending update message to their IBGP neighbor. So in the update there is only AS 100. When router 4 will send this update message to router 5, will it include their AS number? Yes. So AS number will be 100 and 200 in the update message. When router 2 will share this network information to their neighbor, will it include AS number? Yes. 100 will be there, 200 will be there, and 300 will be there. After that, when router 6 will share same update message to router 1, will it include AS number? Yes. So how many AS number will be there, guys? 100, 200, 300, and 400. And whenever router receive update message with their own AS number, it will discard it. Getting my point? This is the rule in case of EBGP. So see, router 1 is receiving one update message. In that update message, router 1 is getting their own AS number, that is AS 100. Yes or no? So it will not accept this update message. This is how loop will not form in case of EBGP. Is it clear?
Yes.
Okay. So let's say I have router 1, not like this. Yes, router 1, then router 2, then router 3. All are connected like this. Here AS number is 10, here AS number is 30, here AS number is, let's say, 20. Okay. And router 1 have one prefix, that is 10.1.1.0/24. So router 1 will send update message to router 3. It will include their AS number. When router 3 will share to router 2, it will include their AS number. So there will be two number of AS in update message, 10 and 30. When router 2 will share this update message to router 1, there will be AS number 10, 20 and 30. And once router will see their own AS number in the update message, it will not accept it. Fine. Okay. After that, okay, we will discuss how to break the rule. Okay, also, because this rule is fine here, but never we need to break this rule. This is the rule. We cannot do anything with this rule. Okay, This is the rule of eBGP. But in case of iBGP, as I told you that in this type of scenario, I need to break that rule. Rule of iBGP, not eBGP. We don't need to break eBGP rule. Fine. Now let me discuss the another topic, that is next hop rule. Whatever rule we had discussed in IGP protocol, I am going to discuss again in BGP also. So next hop, these are, or you can say, concept of BGP in BGP, in eBGP. Let's say, let me discuss one by one. eBGP, one second guys, don't worry. Okay, next hop rule in case of eBGP. So whenever router share prefixes to their eBGP neighbor, router always modify next hop address. Let's say I have three router 1, router 2, and router 3. I am discussing in case of eBGP first. So let's say these routers are connected like this, and here I have this is router 1, R1, R2, R3. Let's say router 1 have one network, that is 10.1.1.0/24. Okay, here I am using AS number on router number 1 is 10, AS number on router number 2 is 20, AS number on router number 3 is 30. Okay, so when router 1 will advertise this network information with update message, it will send what? Next hop address. It will send next hop IP address, what? Self will be 0.0. If I will talk about the BGP table of router 1, this is, let's say, BGP table of router 1. Router 1, once you will advertise this network in BGP, it will install this network in their BGP table with two symbol star and greater than 10.1.1.0, and next hop IP address for this network will be 0.0.0.0. Okay, so 0.0.0 next hop means self advertised prefix. Okay, this is interview question. Interviewer can ask you how to check self advertised prefix in on router. Okay, after that, when router 2 will receive the update message, it will also update their BGP table. It will install this network in their BGP table with symbol star and greater than network 10.1.1.0/24, and next hop IP address will be 12.1.1.1. Here IP address of this interface is, let's say, 12.1. Next, this interface IP address is 12.2. This interface IP address is 23.2, and this interface IP address is 23.3. Okay, after that, router 2 is going to share the update message to router 3. In the update message, it will include the AS number because it is sending to their update message to their eBGP neighbor. Then router 3 will also install this network information in their BGP table with symbol star and greater than 10.1.1.0/24, and next hop IP address will be what? 23.1.1.2. So rule is very clear that whenever router share update message to their eBGP neighbor, it will always modify next hop address. But if router are sending update message to their iBGP neighbor, it's never modify next hop address. So let's say in this topology, in the same topology, not on router number 1, here I am using AS number 10. Here also and here also I am using AS number what? 10 and 10. This time, let me erase the table. This is iBGP. Now you can see on all routers I am running same AS number. Now this time router 2 will learn this network with symbol star and greater than 10.1.1.0/24, and next hop IP address will be 12.1.1.1. When router 2 will advertise it to router number 3, it will not modify the next hop address. So router 3 will install this prefix 10.1.1.0/24 and next hop 12.1.1.1. Now this prefix is not best. Now this prefix is not best as well as valid. Why? Because this next hop address is not reachable from router number 3. Can router 3 ping 12.1.1.1? No. So what is option? Option is here we can configure one IGP protocol. We can configure OSPF for EIGRP. Okay. So rule is when router share prefix to their IBGP neighbor, router does not modify next hop address and it will also not send 0.0.0 as next hop address. By the way, see here, router 2 will not share 10.1.1.0/24 prefix to router 3, but suppose we have break the rule, because this is IBGP rule that router 2 will not share the 10 prefixes because it have received from their IBGP. Yes or no? Router, by the way, router 2 should not forward this prefix to router number 3. But let's say I have break the rule. So router 2 is forwarding to router 3, but still it will not modify the next hop. If you will break the rule also, then also you can see router 3 cannot install this prefix in their routing table. This is BGP table. Router will install it only in BGP table. 12.1.1.1 is not reachable to R3. So 10.1.1.0/24 will be only, this prefix will be only valid here, not best. On router number 3, this prefix will be only valid, not best. So if a prefix is only valid, not best, router never share share those prefix to their neighbor, and router neighbor install that prefix in their routing table. Router install only the prefix which is best as well as valid in their routing table. Done. Done, guys. Let me make you familiar with this topology. Here I am going to, let's say, first I am going to remove the BGP configuration from all routers. Say no router BGP 100. On router number 2 also I am going to run this command, no router BGP 100, and on router number 3 also I am going to say no router BGP 100. Okay, here I am going to connect one, let's say, okay, fine, one more router. This is my here, let's say I am running BGP 100 and this is BGP 200. Here in this domain I am going to connect one more router, router 3, router 4, and let's say router 5 also. And router 5 have also one prefix. Router 5 have also one network. Router 5 have one network, that is let's say 50.1.1.0/24. This is my topology, let's say. Between router 3 and router 4, I will use 34 network. 34.1.1.0/24. First of all, let me configure the scenario. And between router 4 and router 5, I will use 45 network. 45.1.1.0/24. Okay. On edge router, here which router is edge router? R2 is edge router because this is like this. Here, let me delete this, and BGP 200. Router 2 is my edge router because router 2 is connected with both, yes, BGP 100 also and BGP 200 also. Okay, now go to R1. Here I am going to say on R1 I am going to say router BGP 100, router BGP 100, and neighbor 12.1.1.2 and remote AS. Remote AS is 200, let's say. Okay, let me do like this. Okay, so on router 2 is in AS number 200. Fine. Okay, router number 1 I have configured this. Okay, and network 10.1.1.0 mask 255.255.255.0. Guys, between router 1 and router 2, which type of neighborship is there? Neighbor 12.1.1.1 and remote AS is, I am going to say 100. So which type of neighborship will come up here? IBGP or EBGP?
IBGP.
IBGP or EBGP?
Oh, sorry, EBGP, sir.
EBGP. Okay, and router 2 have received this prefix, 10 prefix. So IP route BGP 10.1.1.0. So IP BGP, in BGP table you can see next hop IP address is 12.1.1.1. Okay, now on router number 2 I am going to say there is one more neighbor, IBGP neighbor router BGP 200, and neighbor is 23.1.1.3 whose remote AS is same 200. So here which type of neighborship will form? IBGP. So when router 2 will see here 10 network to their IBGP neighbor, will R2 update next hop? Will R2 update next hop?
Yes.
No.
No, brother. IBGP neighbor. Remote AS 200 and neighbor 34.1.1.4 whose remote AS is 200, and I am going to configure IP address as well on F1/0, that is no cert, and IP address is 34.1.1.3 255.255.255.0. So IP BGP, see, this network is only valid, only a star sign is there, yes or no? Greater than sign is missing, that means this prefix is not best. Why? Why?
Because it is learned via this edge router.
Because this next hop address is not reachable from router number 3.
Yes.
12.1.1.1 is not reachable from R3. R3 cannot ping 12.1.1.1. See. So on edge router, you can run one command, that is next hop self. I can tell to router 2 that whenever you will share any network information to R3, you should update the next hop self. But this command is applicable only on edge router. This command is applicable only on edge router. See, router 2, there is IBGP neighborship between router 1 and router 2, and there is EBGP neighborship between router 1 and router 2, and there is IBGP neighborship between router 2 and router 3. So router 2 is your edge router. So on R2, you can run one command. I can say neighbor 23.1.1.3 and next hop self. Next hop self, this command. When I will run this command on router number 2, router 2 will update the next hop. Now on router number 3, you can see on router number 3, so IP BGP. Just wait, clear IP BGP star soft in and so IP BGP. Now you can see this network is valid as well as best. Why? Because this time next hop IP address is 23.1.1.2 and 23.1.1.2 is reachable from router number 3. Getting my point? Is it clear? Okay, now I am going to configure R4. When router 3 will share this network information to R4. So R4 is which type of neighbor of R3?
IBGP.
IBGP. So again it is not going to update. Next hop IP
Next
address.
hop,
So interface F1/0 no set and IP address is 45.1.1.4 255.255.255.0. Here I am going to configure BGP, router BGP 200 and neighbor. Who is neighbor? 34.1.1.3 and remote AS is 200 and there is one more neighbor 45.1.1.5 and remote AS is 200. Done. Neighborship, you can see neighborship has come up and now show IP BGP. Why there is no any prefix in BGP table? R3 show IP BGP neighbor, sorry, show IP BGP summary. 45 is idle, okay, and 34.1.1.3 is fine, okay. So IP BGP, it is not receiving this 10 prefix. Router 3 is receiving 10 prefix, so IP BGP it is valid as well as best. But router 3 is not advertising it to router 4. Why? अब तो बोलना पड़ेगा आपको. Why router 3 is not advertising to R4? भाई IBGP से लिया हुआ प्रीफिक्स IBGP को देगा?
No.
Router 3 have learned this network from which neighbor? From their IBGP neighbor. So this is rule. So that's why it is not advertising it. Okay, let me configure R5 as well. So this is the reason why I have taken 4 router in this domain, in 200 domain. Interface F0/0, no set, IP address 45.1.1.5 255.255.255.0. Exit interface loopback 1 and IP address is 50.1.1.1 255.255.255.0. Router BGP 200 and neighbor 45.1.1.4 whose remote AS is 200. Now I am going to advertise 50 network. So will R5 share 50 network to R4? Yes.
No.
Why not? Because this is self-advertised prefix. Router 5 is not receiving this prefix from their neighbor. Yes or no? Mask
Yes.
255.255.255.0. So IP BGP. So 50 network is there. this is only a star sign is there. Just wait for some time. So IP interface brief exclude unassign loop back 50.1.1.1 and so IP route 50.1.1.0 is there. So IP BGP done. Next hop is 0.0.0. Okay, go to R4 and see on R4. So IP BGP. So it is receiving 50 prefix, but R4 will share to router 3 or not? Will R4 share this network information to R3? पहले बोलो आप. Will R4 share this 50 network to R3 or not? R4 have received this network information from their IBGP neighbor and R3 is their other IBGP neighbor. No? So you can see. So IP BGP. It is not advertising. Okay? Why? Because we have rule of loop avoidance mechanism. Guys, see how to break the rule first. Rule is what? By default all routers are server. By default all routers are server router. Okay, and rule is very simple. If a router will receive a prefix from server, okay, like R4 is the server which is receiving prefix from their other server, will never advertise. Sorry, not server. By default all routers are non-client. Let me check. By default, where's my mobile? Here it is. By default all routers are non-client. So router who will receive prefixes from their non-client neighbor, by default all routers are server and their neighbor are client. Okay, like R4 is the server and their neighbor router 3 and router 4 is client. Okay, R5 is the server, their neighbor is client. ओके, सो क्या कहते हैं ना, बीजीपी में रूल क्या है, वो जो आपको लूप अवॉइडेंस का रूल है, ये रूल ये कहता है कि एक नॉन क्लाइंट से लिया हुआ प्रीफिक्स दूसरे नॉन क्लाइंट को नहीं देगा. अ सर्वर will never share the prefixes to their non-client neighbor which router have received from their non-client neighbor. Okay, so here I am going to write the rule. Non-client, then server. If a server is receiving some prefixes from their non-client, so it will never advertise to other non-client. So see in the scenario how it's working loop avoidance mechanism. R4 is the server and their neighbor are non-client. So server will receive prefixes from non-client and it will never advertise to their other non-client router. Okay, but if a server will receive prefixes from their client, so it will always advertise that prefix to their non-client as well as client. Okay, if server will receive prefix from their non-client, then server will not advertise to their other non-client. Getting my point? What I am saying? If the server receive prefixes from their non-client, from their non-client, like R5 is the non-client, this is the server. So router 4 is receiving prefix from their non-client neighbor, so it will never advertise to their other non-client neighbor, but it will advertise to their client neighbor. So what I can do, I can tell to router 4 that router 3 is your client, not non-client. By default, all routers are server and their neighbor are non-client. And rule is very simple and very clear, that whatever prefixes you are receiving, a server is receiving from their non-client, will not advertise to their other non-client neighbor. This is the actual rule of IBGP loop avoidance. Okay. So now guys, solution is, if a server receive prefix from their client, will advertise those prefixes to their other client neighbor. If a server is receiving prefixes from their client, then it will advertise to non-client as well. Okay. Only one scenario, in only in one scenario server is not going to share the prefixes, when server is receiving from their non-client neighbor to their non-client neighbor. It will not share the prefixes to their non-client neighbor. Okay. So on router number 3, let's say router 3 is not advertising 10 prefixes. Router 3 have 10 prefix. So IPBGP, yes, but it is not advertising to router number 4, because router 3 is server and their neighbor are non-client. So non-client, router 2 is non-client, router 4 is non-client. It is receiving prefixes from their non-client neighbor. It will not advertise it to their other non-client neighbor. So we have two options. Either I can tell to router 3 that router 2 is your client, or router 2 is your non-client but router 4 is your client. So it will start advertising 10 prefixes. Okay. Is it clear? क्लियर है? इसको हम लोग क्या बोलते हैं? राउट रिफ्लेक्टर. दिस इज नथिंग बट राउट रिफ्लेक्टर इन बीजीपी. राउट reflector. Route reflector is used to break the rule of loop avoidance in IBGP. It is used to break the IBGP loop avoidance mechanism. Route reflector. It is used to break the IBGP loop avoidance mechanism. We have three types of router in route reflector. Route reflector server. We have three types of router in route reflector. First one is route reflector server. Then second one is route reflector client, and third one, last one is route reflector non-client. And as I told you that by default all routers in BGP is server and their neighbor are non-client. Okay. So router neighbor share the prefixes received by non-client neighbor. When server will receive prefixes from their non-client neighbor, it will not advertise to their non-client neighbor. Say not here. Not. Okay. If server receive prefix from their non-client neighbor, then server will not advertise to other non-client neighbor. But if a server will receive prefixes from their client neighbor, it is server is receiving prefixes from their client, so it will advertise to their non-client. Non-client, say yes here. Yes. If a server is receiving prefixes from their non-client, then also it will advertise to client router. Yes. Okay. And scenario can be if a server is receiving prefixes from client, then it will advertise to client. Only 4 scenario is there. Okay, so we have 2 options here on router number 3. See, router 3 have 10.1.1.0/24 prefix. It have received from their non-client neighbor. So we have 2 options. Either I can tell to router 3 that your neighbor 23.1.1.2 is client. So now it is receiving this prefix from client, so it will advertise to non-client neighbor. Yes or no? So R4 will get these prefix. Or what I can do, I can tell that your neighbor 4.4 means 34.1.1.4 is client. Then also it will, receiving prefixes from non-client, so it will advertise to client. Okay. So on router number 3, I am going to break this rule. Let me take you to R3, guys. R3, and on R3 I am going to say router BGP 200 and neighbor 34.1.1.4 route reflector client. Route reflector client. Now you can see neighborship will resynchronize, and on router number 4 you can check so IP BGP. It have received this network, but problem is what? Next hop. Still problem is next hop 23.1.1.2. 23.1.1.2 is not reachable from R3. So still problem is there. R3 is not advertising 10.1.1.0/24 prefix with their next hop IP address. We cannot run next hop self command on R3 as well, because R3 is not my edge router. See, on router number 3, if I will say neighbor 34.1.1.4 and next hop self, it will not work. On router number 4, still you can see next hop is, it will not work. This command is applicable only on edge router. So here I cannot run this command. Let me remove it. Now again, what is solution? First option, we can configure one static route here. Yes or no? I can configure one static route on router number 4 for this next hop IP address. Config T IP route, because this network you can see is only valid, not best. So I am going to define one route for next hop IP address 23.1.1.0 255.255.255.0 and exit interface is F0/0 for this network. Okay, this is the solution. Do so IP BGP. Now you can see this network is valid as well as best. But this is not the way, guys, which we are using. Here I cannot configure a static routing. Second option is I can advertise this network 23.1.1.2 in BGP. So if I will advertise this network in BGP, then also router 4 will receive it. First of all, let me say no to a static route. No here. And so IP BGP. Wait. Do clear IP BGP star soft in. And so BGP. Again you can see. Now this time what I am going to do, on R3 I am going to advertise 23 network in BGP. Network 23.1.1.0 and mask 255.255.255.0. Okay, it will now R3 will share this network also to R4. So on R4 do so BGP. You can see again this network is valid as well as best because 23 is also there. Now this next hop IP address is reachable. But generally we are not advertising WAN link in BGP. Okay. So I am going to remove this command also from R3. Generally we will not advertise WAN link in BGP. Now third option is route map. Here we are starting the use of route map in BGP. Okay. The actual way that we will use here is route map. Whenever you will receive a prefix from R3, please put next hop 34.1.1.3. I can configure the route map on R3. You can configure route map on R3 only for one purpose, that whenever advertise prefixes to R4, put next hop IP address always what 34.1.1.3. Getting my point? Okay. Or I can configure route map on R3 as well. For now on router number 3 you can see this network is not best. So that's why do so IP.BGP. IP.BGP. This router will not install 10 network in their routing table. You can see only 50 network is there. Okay. So I am going to create one route map here. Say route map and then route map name. Route map name is, let's say, next hop. Who is this? Next hop, and after that permit. With permit statement you will create one route map and then you will set IP next hop. What next hop IP address you want to set? 34.1.1.3. 34.1.1.3 exit. In the route map, just I have defined one statement, set IP next hop 34.1.1.3. Now I am going to use this route map with BGP. Router BGP 200 and say neighbor. Who is neighbor? 34.1.1.3. For this neighbor use route map. I am going to use route map with this neighbor. What is the name of route map? Next hop and direction. In which direction you want to use this route map? In direction. So now router 4, whatever prefixes router 4 will receive from their neighbor, from this neighbor, it will use route map, and in the route map we have set the next hop IP address 34.1.1.3 and do so IP BGP. Now just wait, do clear IP BGP star soft in and so IP BGP. Now on router number 4 I'm not receiving. What happened? Wait. So IP BGP. Now it have stop receiving 40 a prefix from router number 3. So route map, we don't have any match as well. So run section BGP. Route map name is wrong, guys. Here you can see. Yes, Nirav. So I am going to remove this command and I will run command again. Router BGP 200. Say no, because route map name is wrong. Neighbor 34.1.1.3 route map, and name of route map is next hop and direction in, and clear IP BGP star soft in, and show IP BGP. Now you can see problem solved. Yes or no? Yes or no?
Yes, sir.
So now this prefix is valid as well as best, so it will, router 4 will advertise it to their neighbor, to R5. Yes or no? Will it advertise, guys, to their neighbor, to R5? Okay, if it is not advertising, then you tell me why it is not advertising now. Now we have discussed lots of time this concept, this rule. Nirav,
Yes, sir.
why router 4 is not advertising to R5? Because again you can see router 4 is server, this is non-client, this is non-client. So the prefix, so router 4 is receiving prefix from their non-client neighbor, it will not advertise to their other non-client neighbor. So on router number 4 I can tell to router 4 that your neighbor router 5 is server or client, anything. Okay, so go to router number 4 and say what? Router BGP 200 neighbor 45.1.1.5 and route reflector client. Okay, now you can see on router number 5, so IP BGP it is receiving, and next hop IP address is still problem. Yes or no? Again we have to modify next hop address, so again I can create the route map. So IP route BGP, it will not install this prefix in their routing table because this is only valid. So IP route BGP, you can see, so IP BGP, this is only valid. So I can create the route map again or not. Either I can create route map on router 4 or router 5. You tell me on which router you want to create. If I will create the route map on router 4, then I will apply it in odd direction with neighbor router 5. If I will create the route map on router number 5, I will apply it in direction like on router 4. So tell me on which router you want to create the route map. Router 4. This time I am going to create on router number 4, let's say. Route map, and the name of route map is, let's say, PM permit. In this route map I am going to set IP next hop 45.1.1.4 na? Yes, 45.1.1.4. Exit router BGP 200 and neighbor 45.1.1.5. Use route map whose name is PM, and in which direction? Odd direction. Whenever you will out any prefixes to this neighbor, you will use route map, and on route map You can see I have set the next hop 45.1.1.4. Done. That's it. Now on router number 5 you can verify. So IP BGP clear, IP BGP star soft in, and so IP BGP. Done. So now hardly router 5 have installed 10 prefix in their routing table. Okay. Now can 10.1.1 communicate with 50.1.1.1? No, it cannot communicate because see on router number 4 we have both networks, so IP BGP 10 also and 50 also, and router number 3 on router number 3, so IP BGP we have 10 network, but see 50 network is only valid, not best. Why? Because of this next hop address. So on R3 now I need to create route map. A route map name is, let's say, CCNA, and permit, then IP set, my god, set IP next hop, and next hop IP address will be what? 34.1.1.4. exit router BGP 200 neighbor 34.1.1.4. use route map. Which route map? CCNA. And in which direction? In direction. Clear IP BGP star soft in, and so IP BGP. Now you can see this network is valid as well as best. So it will install it in their routing table. So IP route BGP, and it will share with their neighbor. 2.2.2. Sorry, router 2. So on router number 2, so IP BGP. See 50 network is there, but again problem is next hop. Next hop address is 34.1.1.4. 34.1.1.4. Rule is very simple in IBGP. Whenever router share prefixes to their IBGP neighbor, it will never update next hop self. So this time I am going to create one route map on router number 3. Say route map, and name is let's say PM, permit, set IP next hop 23.1.1.3. exit router BGP 200 and neighbor 23.1.1.2. use route map PM in which direction? In odd direction. लो अब राउटर 2 पे आ जाओ. थोड़ा सा वेट कर लेते हैं, या फिर आप यस आगे नहीं आया, या फिर आप क्लियर IP BGP स्टार सॉफ्ट इन कर दो. So IP BGP. Okay, valid as well as best. So IP route BGP. It have installed it in the routing table. Now when router 2 will advertise this prefix to R1, will R2 modify next hop? Yes, because R1 is eBGP neighbor. Yes or no? So now on router number 1 you can see so IP BGP. Okay, and now can I ping 50.1.1.1, source is 10.1.1.1. see ping is working. Okay, is it clear to everyone? Now ping is working fine. क्या वो अनीरव हार्ड लग रहा है क्या?
यस सर, हार्ड लग रहा है. ये थोड़ा प्रिपेयर करके लेक्चर देखना पड़ेगा आपका फिर से.
अच्छा, आप बीजीपी इससे पहले आपने पढ़ा ही नहीं है क्या?
नहीं नहीं, मैंने सिर्फ एक बेसिक मेंबरशिप जो फॉर्म करते हैं वहीं तक पढ़ा था उसको, क्योंकि उतना ही रिक्वायर था।
और ये जो कॉन्सेप्ट मैंने अभी पढ़ाया है ना, ये आपको मिलेगा भी नहीं ऐसे इजीली।
नहीं मिलेगा, हाँ हाँ, एग्जैक्टली वही अभी मैं चेक ही कर रहा था ऑनलाइन, ये एनआरसी वगैरह में, कि ये तो पूरा पूरा वही टॉपिक है। वही मैं सोच ही रहा था कि अभी आपका खत्म होने के बाद मुझे कुछ और।
लेकिन ऐसा नहीं है, अगर आप इस वीडियो को एक बार और देखना समझ में आ जाएगा।
ओके ओके।
एंड सुनीता, व्हाट अबाउट यू?
Yes, I need to go through the videos 1 second.
अगेन ओके। एंड फैम, fam, is it clear to you, or you also need to go through it?
I will watch again.
You will
Not
watch
one time,
again.
not only one time, maybe 2 or 3 times.
Okay, 2 3 times. Okay, you will configure. If you will configure by yourself, now then your concept will clear. We have other option as well, like I have configure here rod reflector. Your neighbor is client. You can configure other, in other way as well. Fam, do you know Hindi?